This is a brief introduction to Geographical Skills Part 1. Many people associate geography with maps. A map is a simplified plan of an area that uses symbols and colors to represent the features in the real world. There are key features all maps need to contain. The acronym BOLTS helps the geographer to remember all the features needed. BOLTS stands for Border, Orientation, Legend, Title, Scale, and Source. Sometimes NA is also added at the end of BOLTS, which stands for neatness and accuracy. There are three different types of views of the world. Ground view, which is the view from the ground. Oblique view, which is the view from a low elevated angle. And plan view, which is the view from directly above an area, also known as bird's eye view. Maps can only be drawn from the plan view because the scale is the same across the entire area. Now we will talk about types of maps. There are many different types of maps too. There are environmental maps, which show the natural features of the earth, such as land cover, mountains, rivers, deserts, lakes, seas, oceans, as well as urban areas and cropland. There are physical maps, which show the natural features of the earth, such as mountains, rivers, deserts, lakes, seas, oceans, as well as the height of the land and depth of the sea by the use of different colors. There are political maps, which show the human features of the earth, such as country, state, and territory borders, cities, and towns. There are dot distribution maps, which use dots or shapes to represent a single feature, which show the location of the chosen feature, and the size and color of the dots can show different characteristics of that feature. Choropleth maps, which use different shades of the same color to give a quick impression of the pattern formed by the data being shown, with darker shades showing the highest values and lighter shades showing the lowest or least amounts. There are flow maps, which show movement from one place to another, and are useful for showing the movement of goods, migration of people and animals, and transport and communications. And finally, weather maps, which show conditions in the atmosphere such as air pressure, wind speed, and wind direction, and also show the size and location of warm and cold fronts. Moving on to direction. First off, the magnetic compass. The four main directions on a compass are north, south, east, and west. These are referred to as cardinal points, and the phrase, "never eat soggy Weet-Bix," helps us to remember the four main points of the compass. The other points on the compass are divisions between the four cardinal points. These are called subcardinal points. On a compass, the needle will always point towards the magnetic North Pole, no matter where you are on Earth. Once locating magnetic north, you can find the other points of the compass, as the compass directions always remain the same. True north and magnetic north. There's actually a difference between true north and magnetic north. True north is the actual direction of the Earth's geographic North Pole. Direction indicators on maps point to the geographic North and South Poles, the furthest points north and south of the equator. Meanwhile, magnetic north is the direction in which a free-swinging magnet, like a compass needle, will always point. The changing position of the magnetic poles is thought to be due to the Earth's rotation and the movement of minerals within the Earth's mantle. Let's talk about bearings now. Compass bearings are more precise as they give an angle. A compass is a circle made up of 360 degrees. A bearing is an angle that is measured clockwise from 0 degrees or north. We can use a protractor to work out compass bearings on maps. In the table, we can see that north is 0 or 360 degrees, south is 180 degrees, east is 90 degrees, and so on. Finally, wind direction. When referring to wind direction, we talk about where the wind is blowing from. For example, a northerly wind blows from the north towards the south. You can determine the wind direction on a weather map if you remember that in the southern hemisphere, air circulates in an anti-clockwise direction out of a high-pressure system and in a clockwise direction into a low-pressure system. scale. We use scale to shrink or increase the size of real-world objects to fit in the space. Every feature on a map must be scaled down or up by the same amount, so that the features are the correct size in relation to one another. One unit on each image represents a number of units in the real world. Note that the word represents is used, and not the word is, as they are not actually the same size. The colon is used instead of the word represent for simplification. For example, if something has a scale of 1 to 2, it means that one unit on the image represents 2 units in the real world. If it is the other way, then the larger number will be on the left of the column. Large-scale maps show detailed information about an area, while small-scale maps show basic information about the area. On a map, scale can be shown in 3 ways. The first is a scale statement, which describes the scale in words. For example, 1 centimeter on the map represents 30 kilometers on the ground. The second is a line scale, which acts like a ruler against which you measure distances on a map. This is shown as an example in Figure 1. The third and last is a representative fraction, which shows that 1 unit on a map represents a number of units in the real world. For example, 1:3 million means that 1 centimeter on the map represents 30 kilometers on the ground. Finally, we will talk about location. Alphanumeric grid references. Maps such as those found in shopping centers, street directories, and atlases are overlaid with a grid to make it easier to find features. The space between grid lines is given a letter along the top and bottom of the map, and a number along the sides. This type of grid is called the alphanumeric grid. The grid reference is found where the lettered column meets the numbered row. Latitude and longitude. Latitude and longitude form a grid of imaginary lines that cover the globe. They help us accurately locate places. Lines that run from east to west are referred to as latitude, and lines that run from north to south are called longitude. The lines of latitude midway between the poles is known as the equator. The equator divides the Earth into the northern and southern hemispheres. Lines or parallels of latitude are measured in degrees north and south of the equator. The prime meridian, which is 0 degrees longitude, runs through Greenwich in England. Lines or meridians of longitude are measured in degrees east and west of the prime meridian. Each degree is further divided into 60 minutes to make measurement even more accurate. Finally, the PQE method. The PQE method is used by geographers to identify trends and patterns in data and draw conclusions. PQE stands for pattern, quantify, and exceptions. There are 3 steps to follow when using the PQE method to describe maps. First, the pattern, which gives a general overview of the pattern, referring to particular places. The second, quantify, which quantifies the general overview using data from specific regions or countries. And finally, exceptions, which point out any exceptions to the pattern that has been described. Hope you learned something today, and thank you for watching this video. See ya!